Okay, so I'm here to report one new mineral, maybe two new minerals to caves from Malpais National Monument. From Big Skylight Cave. So Big Skylight Cave is in the Bandera flow, and the different colors are different flows in Malpais National Monument. And it's a beautiful place, and sometimes there are obstacles that you have to get around, but if you get pumped up enough, you can overcome those obstacles.
Younger than.
I was younger. This is Big Skylight Cave. Looking into the cave from the big skylight, from under the big skylight. And you can see the beautiful lava shelves and grooves in this cave. And these patches here, kind of hard to see, but that's the gypsum crusts in the cave. Here's a map of Big Skylight Cave. It's about, judging from this, about 300 meters long or so. Here's the entrance. There's the big skylight. There's a big lava bench here. And the gypsum crust with the minerals was collected, I think, right in here. This was part of an inventory that we did. We had a project that lasted several years. And I took some temperature and relative humidity measurements with my sling psychrometer, and the relative humidity in the cave is 65 to 71% from those measurements in March 2002. So I'm guessing that in the summertime it's probably the relative humidity is probably a little higher. And this, you mentioned Gary Davis earlier. This is a sketch map of probably Four Windows Cave by Gary Davis in 1969 by the Sandia Grotto. I just threw it in. They had a name for the cave then. This is Paula on that lava bench under the skylight. It's trying to stay warm. She was taking notes, inventory notes at the time we were doing the inventory of the cave. And this is a look at the gypsum crusts on the walls in the cave. They're spotty, but they're still there, still preserved. And that's Linda and Paula. And this is a close-up of these gypsum crusts. They're up to almost an inch thick in some places, usually about a half an inch thick. And this is the spot that has the new mineral or minerals. And it's yellow. You can see it's bright yellow. And this is the area where we saw this in the cave. So it's a small area, but we didn't look real hard. And there's some white powder on top, probably mirabilite or vanadate. So we collected this in 2008, and we finally analyzed it this year. Paula and I were going to do this earlier, but we thought, well, this is probably just elemental sulfur, so we just need to verify it. We never did verify it. So I talked to Mike Spilde and said, would you look at this? And he said, oh, yeah. So we had our first session. This is a sample. It's only about a centimeter by a centimeter in size. It was a small piece that we collected. It was part of a project studying the gypsum crusts in the lava tubes in the monument that I started years ago, and I had a student work on it. So the bulk stuff is gypsum. And so we noticed some other things. These bundles of fibers, they're strontium sulfate, almost probably celestite, or otherwise known as celestine. And then there are these squiggly things here. And those are, you can't see it, but it's sodium sulfate. So it's either probably mirabilite or vanadate. In cool caves, mirabilite exists if the relative humidity is above 64%. I measured 65 to 71%, probably not too accurate, but so we're right at that boundary of whether mirabilite exists or vanadate exists. I'm guessing probably both of them do. And then here's the mineral that forms a yellow color. These little blocky clusters of blocky crystals that contain vanadium. So it's some kind of vanadate, and it's a sodium potassium vanadate. So that was a real surprise, expecting to see like elemental sulfur or something like that. So we looked at the list of cave minerals that have vanadium, and there are only 6. And all of them are lead, uranium, copper, or zinc vanadates. So we know this is a new mineral to caves. We don't know what it is yet, though. There's a close-up. The crystals, these are the bigger crystals, and they're 10 or 20 microns in diameter. So we had another session on Wednesday. Mike took another look at the sample, and we looked at some of these smaller crystals that look embedded in the gypsum. And these smaller crystals, 1 and 2 here, were magnesium potassium vanadates. So different than the sodium potassium vanadate that we looked at earlier. And then the third one here is gypsum, and then there's a sodium potassium vanadate. So we have 2 things now, 2 minerals, we think. A sodium potassium vanadate and a magnesium potassium vanadate. Here you can see them together. These kind of a little bit darker material in electron microscopy are the magnesium potassium vanadates, right next to the sodium potassium vanadates. And there doesn't seem to be any evidence of a solid solution. It's like either magnesium potassium vanadates with just a little, maybe just a little bit of something else, or sodium potassium vanadate with just a little bit of something else. So I've been looking at, there are some over 6,000 minerals known. And so I started looking, I'm continuing to look at the vanadate minerals, the vanadium minerals. And there is one mineral, there were 2 here in this family of vanadates that had potassium, magnesium, vanadium. These 2 right here, but this one is black or blue in color, but this one fits one of our minerals. It's reported to have these kind of blocky crystals, and it's yellow. So there's a good candidate for one of our minerals. And then I've recently got on MindDat online, and you can go in and you can click on vanadium minerals, and then you can click on potassium vanadium minerals. And so I've looked at a couple hundred of these and to try to figure out what we have. And the only sodium potassium vanadate so far I've found is this mineral, and it's black and fibrous. So it's probably not that mineral. So I haven't found anything to fit the sodium potassium vanadate. But we, as I said, we have a good candidate for what that mineral is, Hummerite. But we need X-ray diffraction, other analyses to find out more. And Mike did this high contrast image where we can see these clusters of vanadate crystals, and then a lot of them are just scattered around. It's going to be hard to do X-ray diffraction. This clump right here is about a 0.5 millimeter in diameter. If we could get that clump out and put it on a needle and put it in an X-ray machine, we still have the problem that 90% or more of this is gypsum. So, but we have to try. So that's where we are with that. So we think we have 2 new minerals to caves from Big Skylight Cave. And one of them could possibly be a new mineral in itself, but I don't know if we'll ever get there with that. And that's all I have. Well, as I think so, the yellow is the vanadium. And Diana noted earlier that there was a lot of vanadium in some of the samples they were looking at. Basalt has several hundred ppm of vanadium. It can have several hundred ppm of vanadium. And our student who did work on the crust, he was seeing several hundred ppm of vanadium in the gypsum crust. So maybe as a gypsum crust, weather or, maybe it brings out some of the vanadium and precipitates, but I don't know.
Four Windows had a good bit of,
Four Windows has the stuff that has the
Yeah.
vanadium.
and,
Oh, yeah. This is one of the entrances to one of the caves on the Forest Service list in the Zuni Mountains. Yeah.
That Hummerite seems to be maybe a decent candidate. Is it a naturally occurring mineral or is it synthetic?
It's very rare. It is a naturally occurring mineral and it's very rare. Yeah.
This might be a stupid question, I don't know mineralogy, but could you dissolve, on that sample that you want a little bit, could you dissolve?
I thought about that. I just thought about that yesterday. You really, it's a very good question, very good comment. You can do that. You can, but I don't know how soluble this other mineral is.
Might ever go away.
Like if it was insoluble, you could just dissolve away the
Yeah.
gypsum. And you'd think gypsum would be easy to dissolve. When I first started working in the lab, I was trying to do some dating of gypsum, and I was trying acids, trying to dissolve it. And I said, what the heck? It won't dissolve. I know it's soluble in water, but so I went and talked to somebody there working in the chemistry lab, and he said, oh, you just dissolve it in weak acid, but it takes a couple days. So you have to powder it and engulf it in one normal acid and wait. Then it dissolves.
Okay, so thank you very much.